We could just use the escape velocity formula for this, but let's not. Let's just figure it out, right? So we fire it from the surface of the moon with some velocity, right? We don't know what that velocity is, so we'll just say some velocity v, such that when it gets to infinity, it stops. That's the idea of escape velocity. So when it gets infinitely far away, it uses up the last little bit of its kinetic energy, right? Of course, this never happens, right? But it's the lowest velocity where the thing would not come back. Okay? Now, what that means, by the way, when you figure out the total energy of a system, right? When you figure out it's minus gmm over r plus its 1/2 mv squared, right? When you figure this out, if it's negative, it means that you're still in that gravity well. You're gravitationally bound to this object. If this thing is positive, then that means this, the sum of everything in this parentheses. If that's positive, that means you're going to escape and have energy left over. But if it's exactly 0, then that's the minimum velocity you can have, and you never come back. Okay. So what we're going to say is that this plus this is 0. That is, it reaches infinity, so it's got 0 potential, and it's not moving, so it has 0 kinetic. So let's figure that out. Okay. Notice that the first thing we can do, we can cancel the mass of the bullet. I can divide 0 by the mass of the bullet, and I can divide this side by the mass of the bullet. Okay, and then I can go gm over r is equal to 1/2 v squared. I can go 2gm over r is v squared. And of course, v is equal to the square root of 2gm over r, which is the formula. It's in your data packet. It's for the escape velocity, right? Okay. We didn't have to derive it. We could have just pulled it out and used it. So let's do it. Square root of 2 times g times 7.35 E22. And then we're shooting it from the surface of the moon, so that's going to be 1.737 E6. Here we go. Square root alpha F1 alpha G times 7.35. Alpha G only works if you store that number. 6.67 times 10 to the minus 11th in your letter G, which is what I did. All right, let's see. This is, wow, I'm just really not getting, oh, I forgot the 2. I'm really not getting that answer. Okay, hold on. Let's try actually using the formula here. Whoops. Okay. Insert a 2. There we go. Everything's good now. Let's see. So I get 2375.86. 2375.86 meters per second, or 2380 meters per second is the escape velocity. And really all that means is that we just have a net 0 energy, total energy, right? Which is kind of cool.